Hey guys, I'm Sai Teja, and in this video I'm going to talk about regression analysis. First of all, what is regression analysis? It is a study of relationship between the variables, and it is one of the most commonly used tools for business analysis. It is used to make it is easy to use, and it applies to many solutions. Types of regression. There are two types of regression, that is single regression and multiple regression. Single regression is generally a single regression has only a single explanatory variable, whereas in multiple regression or multi-regression has one or more explanatory variables. Here you can see in the equation y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus and so on, beta and xn plus epsilon. Here the y is the dependent variable, that is the single variable being explained or predicted by the regression model, and the x1 x2 and so on xn are the independent variables. These are used to predict the dependent variable, that is these are used to predict the y, and the coefficients are beta naught, beta 1, beta 2 and so on. These are the values computed by the regression tools, reflecting explanatory to dependent variable relationships, and the residuals or the error, that is epsilon, the portion of the dependent variable that isn't explained by the model, the model under and over predictions is epsilon. And the regression analysis, in the regression analysis we have generally two forms, that is linear regression and non-linear regression. Linear regression is just a straight line where we get a straight line, and the non-linear we get a curved relationship. In the graph we get a curve, and these are generally a logarithmic relationships. And coming to cross-sectional, these are the data from the cross-sectional regression is the data which is gathered from the same time period. And similarly, time series, it involves the data observed over equally spaced points in time. And simple linear regression model, as you can see in the figure, it is just a straight line, that is it stands for the linear regression. And here the only single way, we will assume that the independent variable is x, and the relationship between x and y is described as a linear function, and the changes in y are assumed to be caused because of changes in x. And as you can see in the model, all these are linear regression models. And first one is, this is a strong positive relationship because the slope of the this line is positive, so this is a positive strong positive relationship with both the variables. And this stands for negative relationship, and the slope of this slope of this line is negative. And whereas coming to this, it gives no relationship and the slope is 0. And this is the estimated regression model. The sample regression line provides an estimate of the population regression line, estimated or predicted y value, yi equal to b naught plus b1x. Here b naught is the intercept, and b1x, here x is the intercept variable, and b1 is the estimate of the regression slope. And simple linear regression example, if a real estate agent wishes to examine the relationship between the selling price of a home and its size measured in square feet. Suppose let us assume we are taking a random sample of 10 houses, and the dependent variable is y, that is the house price in thousands dollars, and multiple of $1,000, and the independent variable x, that is square feet. And here is a sample data where we are taking y as dependent variable and x as independent variable. Example here, for 1400 square feet of land, it costs $245,000. Similarly, for 1600 square feet, it costs $312,000 US, and so on. And here we are taking like this. And if we apply the regression formula, we get intercept of 98.2843, and the square feet, that is epsilon e is no, sorry, that is the slope 0.10977 into house price into square feet, that is house price equal to x intercept, that is 98.24833, and plus 0.10977 into square feet. And this is a prediction model which we used for the prediction. And while if we use scatter plot for plotting the graph, we'll get a straight line like this, which has a slope of 0.10977, and the equation we get is house price is equal to 98.24833 plus 0.10977 into square feet. For example, if we are given a square feet of let's say suppose 2000, then we'll be getting a house price estimated like 317.85. and that is 317,850 dollars. And the coefficient of determination, that is r square. R square equal to sum of squares explained by the regression divided by total sum of squares. In the single independent variable case, the coefficient of determination is r square equal to r square, where the coefficient of determination is equal to simple correlation coefficient. And if the r square equal to 1, then it shows the perfect linear relationship between x and y. That is 100% of the variation in x is explained by the 100% of the variation in y. And if the value of r square lies between 0 and 1, then it has a weaker relationship between x and y. But not all of the variation in y is explained by x. If r square is 0, then there is no relationship between the x and y. The value of y does not depend on x. Here we can simply assume that if we give y equal x equal to 0 and y equal to some value, so they both are not dependent. Here r square, in the previous example as we calculated, we got the r square of 0.58, and which is lying between 0 and 1, so it does not the y value does not completely depend on x. And the standard deviation of the variation of observations around the regression line is estimated by square root of sum of squares, or sum of squares error divided by sample size minus number of independent variables minus 1. And this can also be given as the standard error of the regression slope coefficient equal to estimate of the standard error of the least square slope divided by sample standard error estimate. And we get adjusted r square, that is a 0.52842 as 41.33032, and SB1 is 0.03297. Thank you.